In this video, I'm going to go over section 5.2, which is probability rules. And so in probability rules, we talk about a sample space. So the sample space is the list of all possible outcomes of a scenario. And then a probability model. So a probability model is some description of a random process that consists of two parts. The first part is that sample space. So it's looking at all the possible outcomes that could occur in that situation, and then computing the probability of each outcome in the sample space. Remember that the probability has to be a number between 0 and 1. So that means that it is a decimal value and a positive decimal value. And then the probability of the sample space, so meaning if I were to add up all the probabilities of each outcome, that's always got to equal 1. So there will be problems where they'll give you all but one of the probabilities and you have to find what the missing one is. So you would like add them all up and subtract from 1 to find that missing value. In the first example, we're going to fill out a probability distribution. And so they're giving us percentages. So a group of marketing researchers for a popular cell phone manufacturer collected the following information about young adults. 1% use a cell phone that is 3 years or older, 2% use a cell phone that is 2 to 3 years old, 20% use a cell phone that is 1 to 2 years old, and 77% use a cell phone that is less than 1 year old. Suppose a young adult was selected at random, let X equal the age of a randomly selected person's cell phone. So they're telling you here essentially, so X is less than 1, so that would be 77%. So again, in a probability model, we want to change that to a decimal because it needs to be a number between 0 and 1. And so if we change, excuse me, 77 to a decimal, 77% to a decimal, that's 0.77. The next one is that the age of the cell phone is a year to 2 years old, which is 20%. So 20% written as a decimal, if I move that 2 to the left, is 0.20. 2% use a cell phone that's 2 to 3 years old, so between 2 and 3. If I move 2%, that decimal 2 to the left, that's going to be 0.02. And then finally, 1% use a cell phone that's 3 years or older, so that's going to be 0.01. Again, a way to check that you did this correctly is that you should be able to add up all of these and it equal 1. So if we add up 0.77 plus 0.2, that's 0.97, 0.99, and then 1. Okay, so that's a way to check to make sure that the distribution is correct, is that they should all add up to 1. Again, there will be problems where one of them is missing. So what you would do is add up the ones that are given and then subtract that value from 1 to find the correct answer. In the next example, we have some distributions that are filled out. A 6-sided number cube is considered loaded if it is not fair. So normally, if I have a number cube, the probability of rolling a 1, 2, 3, 4, 5, or 6 is all equal. It's all 1/6. So this first option is not the answer because that is a fair number cube. Okay, so it's loaded if it's not fair, and that distribution is a fair number cube. So they want us to find the probability distribution for a loaded number cube. So that would mean that the probabilities are different for each outcome. So if I look at the rest of the options, the probabilities are different for each outcome. So I'm going to have to kind of use the other information from a probability model to answer the question. So the first thing is that all of the values have to be between 0 and 1. That means that I'm not allowed to have a negative value for a probability. So that means that I can eliminate this answer choice because of that negative 10% as a probability. Okay, I cannot have a negative probability. The last thing to check is that the probability of the sample space is equal to 1. So again, if I add up all the values and I get 1, then that should be the appropriate model. So if I'm looking at the first one, if I add up 0.05 plus 0.12 plus 0.23 plus 0.1 plus 0.24 plus 0.26. If I add up all of these, I get 1. So it looks like that one's going to be the answer, but let's just check the last one to make sure. So then for this one, I have 5 different 0.20s. So if I just do 0.2 times 5, notice that that gives me 1. So that means that if I add the 0.15 to it, I'm going to get 1.15, which is not 1. And so the distribution for a loaded number cube would be that second option. The next thing that they talk about is sample spaces for more complicated events, complex events. And so the sample space can become more complicated when 2 or more random phenomena occur simultaneously. So for this problem, they want us to determine which of these is the sample space. So we'll write it out and then figure out which one matches. So Reese, Greg, and Brad meet once a week for coffee. They have their favorite cafe. They each have their favorite cafe. And to be fair, they use randomization to choose how they will meet. Each person has a colored marble, red for Reese, green for Greg, and blue for Brad. Each week, all 3 marbles are mixed well in a bag, and a marble is selected. The favorite cafe of the person associated with the selected marble chosen for that week's meeting. Which of the following represents a sample space for choosing the cafe for the first 2 weeks? So that means that we're doing 2 different marbles. So we'll start with R, because if I look at the answer choices, they started with R as well. So if I'm drawing 2 marbles, I'm putting the marble back each week, right? I'm starting with all 3 marbles each week. So that means that if Reese gets to pick for the first week, Reese could also pick for the second week. So then if Reese picks the first week, the other 2 options are that Greg could pick the second week or that Brad could pick the second week. Okay, so those are all the options in terms of Reese being able to pick first. Okay, so if I look at my answer choices, I don't have a Reese for A. And so that means that I can eliminate A. Okay, so then the next color is green. So let's start with G. So if Greg gets pulled first, Greg could also be able to pick the next week. So it could be Greg, then Greg. After that, if Greg is still first, it could be Greg and then Reese, or Greg and then Brad. Okay, so we should have Greg, Greg. So this one has Greg, 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 Brad, but it's missing Greg, Reese. So that means that B is not the correct answer. Okay, so then if we look at this one, we've got Greg and Reese, Greg and Greg, Greg and Brad. Okay, and then this one, Reese and Reese, Reese and Greg, Reese and Brad. It has an extra Reese and Greg, so notice that that one is there twice. A sample space shouldn't have multiples of the same situation, and so that's going to mean that that's not the correct answer. So let's make sure that the rest of ours are as follows. So if Brad is picked first, right, it could be Brad and Brad, Brad and Reese, and Brad then Greg. So we have a B and R, B and G, B and B. So that means that C is the correct sample space. So again, we're looking at drawing the marble with their color. for 1 week and then the other week. And they always start with all three of them have an equal shot each week. So that's why we're allowed to repeat. The same person can pick 2 weeks in a row. The next concept is mutually exclusive events. These are also called disjoint events. These are events that cannot occur at the same time. So what we're looking at in this lesson is mutually exclusive events. So if I have in a Venn diagram 2 different events, their outcomes are completely separate. There is no overlap. What we'll see in the next lesson is non-mutually exclusive events. So that's when they do have some kind of overlap. And so what we're doing with our formula will change in terms of this. So when I'm looking at the probability of probability of mutually exclusive events, I just have to add up the 2 probabilities of the 2 different events. So in this example, sports science researchers determined that for those people who skateboard, 22% have never had an injury, 45% have had 1 injury, 18% have had 2 injuries, and 15% have had 3 or more injuries. What is the probability that a randomly chosen skateboarder has 1 or 2 injuries? Okay, so we want the probability that a skateboarder has had 1 or 2 injuries. And to do that, we're going to take the probability of them having 1 injury, and we're going to add that to the probability of having 2 injuries. So these are mutually exclusive. 1 and 2 are completely different numbers. There's no overlap between only having 1 and only having 2. So the probability that someone has had 1 injury is 45%, and the probability that someone has had 2 injuries is 18%. So we're going to convert those to decimals. So 45% is 0.45, and then 18% is 0.18. So if we add up the 0.45 plus the 0.18, we're going to get 0.63. So that is the correct answer for this problem. The final concept that they talk about in this lesson is the complement of an event. So the complement is the fact that the event doesn't occur. So if we're looking at a Venn diagram, which again, they'll go deeper in the next lesson, the box represents my sample space. The circle represents event A. So everything else in the sample space that isn't in that circle, that's the complement of A. The formula that we'll use for this is that the probability of the complement of A is equal to 1 minus the probability of A. So we'll talk about that in 2 different ways in this example. So it's the injury example again. This time we're asked, what is the probability that a randomly chosen skateboarder has not had 3 or more injuries? So that means we're asked for the probability of 3 complement. Okay, so we're looking for the probability, the complement of 3 or more injuries. And so using our formula, that means we're going to do 1 minus the probability that they did have 3 or more injuries, which that percentage is 15%. Okay, so we're going to plug in 15% there as a decimal. So 1 minus 15% is 0.15. And that's going to give us 0.85. Okay, so the probability that someone has not had 3 or more injuries is 0.85. Because they gave us all of the data in this situation, if they didn't have 3 or more, they either never had an injury, had 1 injury, or had 2 injuries, right? So one thing that we could have done as well is added up all these values. And we could do that to kind of check to see if we get 0.85. So if we do 0.22 plus 0.45 plus 0.18, notice that that is also 0.85. Okay, so there was an alternative way to do that simply because they gave us every situation possible in that probability distribution. Okay, so that was everything that they talked about in section 5.2. So remember, the big idea is that a probability model, all of the probabilities must be a number between 0 and 1, and that the sum of all the probabilities in the sample space have to equal 1 or 100%.